Conspiracy theories have a lot more to do with psychology than they do with logic, and I want to illustrate that today by dissecting flat earth conspiracy theories so you can kind of see how people think when they engage in this kind of phenomenon and how people actually start to fall for a flat earth conspiracy theory. So let's just start with a basic question, right? In all of conspiracy theory thinking, you have to ask the question, how do you distinguish between a true conspiracy and a false one? And that really leads us to the question, how do we know anything? Now, usually when we come to claim to know something, we're basing our knowledge on things that we already have kind of stored in the background of our head. So think of your mind as like full of all of these different propositions that you've already accepted as true. And some of those propositions are true, and some of those propositions are false. Why? Because none of us are omniscient, we don't know everything, and some of us do hold, all of us I'm sure have at least one false belief at some point in our life. So therefore, we have all of these beliefs in the background, and when we are presented then with new information, we try to fit that information to stuff that we already know. So if you know a lot about science, or you know a lot about physics or logic, then you're probably going to understand why the Earth is spherical or spheroid, and you're going to understand the basis behind that. But if you don't know a lot about science, or if you've not heard a lot about logic, then you're probably going to fall prey to some of the mistakes that many people use when they're arguing for flat Earth conspiracy theories. So it's that conjunction of taking new data and then applying that to what you already know that leads us then to make certain conclusions that diverge people from, conspiracy versus anti-conspiracy theorists. And that's what makes things dangerous, is that sometimes people construct a worldview in your own mind. Notice that most of it is imaginary, that they just say, here, have you considered this? Or have you ever thought about this? And that by putting those things into your imagination, then inserting new data into your mind at that moment when you have that imaginary framework or structure already in place, it then leads you to start building a worldview that's based on flat earth reality or something like that. And so that's how people construct these realities, right? This is where a lot of conspiracy thinking begins. So let's talk a little bit about the conspiracy theorist strategies, because I think this is a good way to tell when somebody's trying to pull your leg. So one of the first things they do is to cast suspicion on the dominant view. Conspiracy theories are oftentimes flying against the dominant view of what science says, or what academia says, or what the government says, or what religion says, or whatever it is that you're trying to oppose in this scenario. And so they try to cast suspicion on the government, or they try to cast suspicion on religion, or they try to cast suspicion on science to say, right, do you really know that these things are true? And so if they can get you to doubt that, that's opening the doorway, that is, they're eliminating some of those beliefs that may actually be true in your mind, to open the doorway to start inserting and replacing those dominant beliefs with other non-true beliefs or conspiratorial beliefs. Then they start to introduce you to personal observations and say, look, you need to check this out for yourself. And that's what sounds logical, right? That is, the idea that you should be investigating things for yourself and relying on personal observation is supposed to be a testament to something that sounds scientific. But as many people have pointed out, the lowest denominator for scientists is personal observations, right? Science goes way far beyond that in its processes of induction and repeated controlled experiments and double-blind experiments and understanding the nature of how the universe works. But most people don't have that expertise, knowledge to fall back on. And so personal experience or personal observations are the best thing that you can use. And that's where people start to make mistakes, right? So people can oftentimes use your personal observations without understanding the physical world, or understanding chemistry, or understanding how light operates, or things like that. Then they construct a new worldview on those personal observations by saying, okay, now you see these things, right? Perhaps you look at the world and you see it looks like it's flat. And then they start to construct a worldview now that they've cast a doubt on the dominant position, and now that they've inserted some of your own personal observations, they then start to construct through imaginary means, right? Notice they're not oftentimes showing you evidence, but they might show you a picture or something like that to get you thinking in a new way. And that's when you start to build a new set of beliefs that lead to a totally different worldview. So that's the strategy. And again, I can't stress this enough. The origin of conspiracy theories begins with imagination. So this reliance on personal observation is what conspiracy theorists are using to try to justify their position. And so they'll look at some weird odd anomalies that you may see in a photograph or things that you might see in your personal life. And they say that's what you should be basing your scientific knowledge on, unaware of the fact that sometimes our observations are mistaken or that we're not seeing the full set of data. So this is actually appealed to in the president of the International Flat Earth Society, Daniel Shenton, when he says, I don't think that there is solid proof. I'm not intentionally being stubborn about it, but I feel our senses tell us these things, and it would take an extraordinary level of evidence to counteract those. How many people have actually investigated? Have you? Right, so they're actually asking the question, have you ever tried to prove that the world is spheroid? I mean, how many people actually go to do that? Or do you just trust your teachers, or trust the media, or trust your government leaders, or whoever it is that is in authority? That's what they're really appealing to, is this sort of like everyday people, popular science. That's what it is, right? It's like people trying to do science without any type of scientific knowledge or scientific education. So he's asking people to do this research themselves. And here's a good example of that. They oftentimes will show you a photograph of the Earth, and they'll ask you if you see anything weird in that picture. This is actually how the flat Earth conspiracy theory was introduced to me. Someone was trying to convince me that because there's something weird about this photograph of the Earth, that might imply that the Earth might not be spheroid. So, do you see anything unusual about this picture? Some people actually claim that they can see in the picture writing in one of the clouds. They believe that these clouds over here actually spell out the word sex. And in some websites, they'll actually highlight those clouds with fluorescent colors to really draw your eyes to it and embed it in your mind. They actually do a strobe light feature on it to get you to see the cloud looking like sex. And so that's a zoomed in picture of it. And the question is, first of all, does that really say sex, or is that our imagination imposing patterns onto nature? Just like you might see images in a cloud when you're looking at it on a sunny day, or you might be looking at toast or a rock formation and you see a face in it. But the thing I wanted to point out is that, look, just because the photograph appears to say sex, right, that doesn't mean that the Earth is flat. What's the conspiracy theorists trying to do? They're trying to cast doubt on the picture itself, saying that because this picture looks like it has the word sex in it, that you can then doubt photographs of the Earth. And that's not a reason to believe in flat Earth, but it does do the job of getting you to dismantle your hold on the dominant view of spheroid Earth. So I would argue that actually those clouds can form many shapes throughout the course of history. And here's a further question I need to ask, is that if NASA intentionally wrote the word sex in the clouds, why would they do that? Right? In order for a conspiracy to work, it's got to be done in secret. So why would NASA give us clues to indicate that the picture is fake? That doesn't make any sense. There's no motivation for it. I can't imagine anyone ever trying to reveal this to other people unless they just don't want the conspiracy to be true. That's actually one of the ways to test a conspiracy theory. Is it possible to maintain such a huge mega secret like the Earth is flat for hundreds of years without anyone coming out and saying, yeah, I forged this, or they leave clues, or you find evidence that it's out there that shows that it's flat? People are oftentimes just ignoring these issues, but instead, they want to say that the Earth actually looks something more like this. So this is actually the common model of flat Earth society, although they don't really agree on what the Earth is supposed to look like. This is just the one that's most common because most of us live in the Northern Hemisphere, and so we can kind of see the Northern Hemisphere as being sort of like the center point. And most people don't go to Antarctica, so we never can confirm that Antarctica is that freaking big around the edge of the Earth. So the idea here is that instead of using the normal map that we would use to describe a flat Earth, they're trying to say that the reason why the Earth is this pattern is that the ocean is kept up through an ice wall that's protecting the Earth and therefore keeping the ocean in its place. Although, as you'll see, that's not always a common agreement about how the Earth actually looks. But this is one of the most common models for it. Placing the North Pole at the center, therefore the South Pole is then expanded outward and leads to this strange phenomenon of Antarctica being really large. Now, if you were to reverse that, and there have been people who have actually argued something like this, although they're much fewer in number, the southern pole doesn't work as well because, as you can see, most of the center portion is ocean, and most of the landmass is in the northern hemisphere, and so it forces the land in the northern hemisphere to spread out. And that's not something that you get in the other picture because, right, Africa or South America comes to a point so that the land masses don't have to spread out as far. But if you flip it around and put the northern hemisphere on the edges of this flat disk, then you'd have to stretch out Russia, you'd have to stretch out North America, and that's easy to disprove because the distances between states and cities could easily disprove that model. But we're talking about real evidence there, and I'm not sure that these flat earthers are actually doing the experiment to test to see what the distances are between all of the cities in the north and the south hemisphere. Now, there are some people who have actually proposed a bipolar model, and by that they mean that the two poles are actually found on either sides of the flat disk, and therefore tried to justify this. But again, the distortion in America and Russia, China and Japan would be so severe, and Australia for that matter, would be so severe that I don't think anyone could take this model very seriously without finding obvious evidence that these cities are not spread out in these ways, or contracted in some of these ways. So therefore, I think we can show those models to be false as well. Now, other people have actually claimed that there is actually more beyond the ice wall. And so some people think that while the Earth is contained within Antarctica, that there may be more water or more ice. And the question for the flat earthers is this: is there an edge of the Earth? And what's on the other side of the edge? And they say, we don't know because no one's ever been there. That's what they claim, even though there have been people who've crossed Antarctica and gone from one side of the continent to the other. They say that those stories are made up and they don't believe that they're really true. In fact, they even appeal to some of the people who have flown over Antarctica and use their quotes out of context to try to justify that. Maybe we'll talk about that in another time. But in the infinite model plane, they actually claim that there may be an infinite ocean outside of that that just expands on for eternity, or for an infinity of space, raising a lot of questions about how the universe is really constructed. So there is a couple of conspiracy theorists that I've been following that actually place other continents behind Antarctica and say that there's other worlds out there that we can see even beyond this. Perhaps worlds that are appealed to in mythologies like Atlantis, or in the Hindu mythology, or other worlds that are appealed to in certain religions. And so they might even expand that to another ice wall and say that there are continents even beyond that. And so there are worlds within worlds, according to this model. All of it is done without proof, unless you take those mythological stories about Atlantis to be real, right? So again, your imagination, if they can appeal to your imagination and say, well, maybe these stories are actually real stories. They're not mythologies. They're not stories to explain, the gods of Anubis or, the Greek pantheon. They're actually real worlds that exist beyond this, and therefore we are just a weird experiment in the middle of a giant cosmic war between factions. You get the point. So in this flat disk, no matter how it's arranged, no matter whether it's infinite or finite, most of the flat earthers today are now saying that the sun and the moon actually rotate in a clockwise formation around the Earth, and that's where you get day and night. Now, this poses a lot of weird questions about how that works. They usually refer to these two light fixtures as spotlights to indicate that the sun's light does not actually cross a certain point of the Earth, and therefore it can still be dark on the other side. But that does raise questions, and how does light work? And that's where they have to posit all sorts of new information, like that there's a dome with refraction of light, or that that the spotlight's only shining on this part of the Earth, which doesn't exactly cover half the Earth, by the way. And we'll talk about some of those objections a little bit later on as well. So notice that when we're trying to understand what is true and what is false, there are two basic forms of justification. There is empirical observations that we make through the senses: seeing, smelling, tasting, touching, and hearing. And then there's a rational justification, which is basically internal coherence with other beliefs. And there are some philosophers that appeal to this as a form of pure reason, right? Descartes did that when he was trying to formulate his first meditations on philosophy, to say that I think, therefore I am, right? He's doing all of his logic in his head, and he's trying to construct our knowledge just based on beliefs that he had. already coherent in his mind, and therefore to try to do philosophy that way. Now that actually does work in things like mathematics. So, all of mathematics is a form of coherency theory. It's pure rational. It's not always based on observation. That is, you can actually deduce what the area is of a circle without measuring all of the circles. You can figure out what the area is of a triangle, or that all of the angles in a triangle add up to 180 degrees without ever once measuring a real life triangle. That is, reason does work when it comes to mathematics, but it doesn't tell us a lot about how the world actually operates in reality. We need observations to check those beliefs, to see if those coherent beliefs correspond with reality. And so what conspiracy theorists are trying to do is to construct a worldview in your head that matches your personal experiences. Again, you may not have knowledge about what's going on in Antarctica or what Earth looks like from space, unless you're an astronaut or something. And those people, they question their legitimacy, they question their motives. So they're trying to construct this worldview based on personal observations without appealing to controlled experiments or knowledge of physics or other background knowledge that would help you here. And that's usually how cults form. That's usually how new religions get started, is constructing a worldview, presenting it to you as if it's true, and without counter evidence to get you out of that cult or to get you out of this conspiracy theory. They then just feed you the stuff that you can see or that you already agree with from your own personal observations. So the point that I'm trying to make here is that we need both of these, empirical observation and reason, to come to a better understanding of knowledge. But that needs to be refined as we grow in our knowledge. And that's where expertise comes in. All of the sciences are not based on personal observations. They're based on a combination of reason and logic and observations through controlled experiments to deduce what the laws of physics, the laws of nature, the laws of chemistry are. And that's what I think we need to do with conspiracy theories, is to figure out, are they coherent? Are they really matching not just our personal observations, but even the broader experiments that we can do in a controlled setting? So you look at internal coherence and you look at the planets and you say, okay, right, why is the Earth flat and all of the other planets spheroid? That doesn't make any sense. And so they have to come up with an explanation for that as well. And so here's a meme that I saw on the internet that said that Flat Earth Society has members all around the globe. And physics-astronomy.com says, say that again, but slowly. I mean, these are jokes, right? Because there seems to be something incoherent about that the planet Earth is flat, but all of the other planets appear to be spheroid. You'd have to say that all of these pictures of other planets are false, but yet, you can make these observations yourself by looking through a telescope. You can even see the moons of Jupiter moving around it. You can, if you have a really good telescope, you can even see Jupiter rotating on its axis. And therefore, personal observations don't always match this. And there is an inconsistency in the flat Earth conspiracy theory. And so, having to address that, there is actually a flat Earth believer who says these words to try to account for why Earth would be flat and the other planets spheroid. He says, the planets are orbiting astronomical objects. The Earth is not a planet by definition, as it sits at the center of our solar system, above which the planets and the sun revolve. The Earth's uniqueness, fundamental differences, and centrality makes any comparison to other nearby celestial bodies insufficient, like comparing basketballs to the court on which they bounce. And you see what he's trying to do here. He's trying to account for this inherent discrepancy, right, that our planet is different from all the other planets, by saying it's not a planet. He's saying that the Earth is something different. It is simply this unusual entity, like a basketball court, and all these other things that are moving around it, they have different properties because they are not the same thing as the Earth. So notice he's not appealing to evidence in this statement. This person is trying to get you to see things in a different way, both to dismantle the dominant worldview that the Earth is a planet, and to then insert other ideas that would help you to say, okay, well, maybe we need to rethink this, kind of like how Copernicus or Galileo changed the way we viewed the solar system. And they're trying to do the sort of the opposite of that by saying, maybe you need to think about the Earth in a different way. Now, observational evidence is oftentimes appealed to. This usually comes back to the author of the Zetetic Astronomy, a guy by the name of Samuel Shenton, who says this: No man knows the ultimate shape of the earth, but that portion that we live on is definitely flat. So he's claiming that, what we see in our personal experiences, that's definitely flat. And so nobody actually knows what the whole shape of the earth looks like. No one will ever know what the whole complexity is like, I suppose, because it goes beyond his sphere of observation, investigation, and comprehension. So notice that he's appealing to things that sound scientific, and they are, in part. Observation, investigation, and comprehension are things that we should be basing it on, but he's saying that this is a question that we can't solve because we don't have full access to that. Now, Samuel Shenton lived before the space program began, so he didn't know what pictures of the Earth look like. He certainly never thought about going into space and being able to investigate these things further. So from his perspective, he's just trying to say that from your personal experience, it looks flat, and he's trying to argue this possibility that maybe it is flat and that the argument that the Earth is spheroid is simply mistaken. That's how I think a lot of this conspiracy theory got started in the first place. So what do people do? They tend to engage in all sorts of name calling, yelling at one another, calling each other names, and we don't really listen to one another. And I think that's what we need is a dialogue between scientists and conspiracy theorists to really try to understand and to dismantle a lot of the mistaken beliefs that are held in that. Let me show you some examples of that to help you to understand how this might work. One of the tactics that a conspiracy theory will do is to ask questions without answering them. And the reason why they're doing that is because they're trying to get you to fill in the spaces. If they can ask you a question, and if you don't know the answer to it, then suddenly you start to doubt the dominant view, you start to doubt yourself, and then you're more open. You're like, you know what, I don't know the answer to this question. But if they ask a question with the hinted implication that it must be flat, then you start to insert the answer yourself rather than just telling it to you, which kind of gets you to start constructing this worldview in the back of your mind. So that's a tactic that they'll use, and I'll show you examples of that in a minute too. They also construct a false worldview through gradual persuasion. This is something I've noticed with a lot of movies. Have you ever watched a horror film? A lot of these horror films invoke things like the supernatural or things like magical properties or things that just could never really come into existence. Zombies or ghosts or whatever it is the Blair Witch was. These things are not real, but they get you to believe it because first they introduce you to just an ordinary family or an ordinary couple who's just going about their life, and you're buying that they're having these experiences, but then they start to just drop these hints that something weird's going on, and that's the asking questions without answering them, like, what is that thing, or what was that noise, or what was that shadow or that thing that passed by? And then once they get you to go further and further down the rabbit hole, they eventually start to construct the world where you are now starting to accept the possibility that it could be the Blair Witch, or it could be, some kind of ghost or zombie or whatever it is, vampires. And then once they introduce those things to you, you're ready to accept them. It's exactly what they're doing in a conspiracy theory. They're trying to gradually get you to start to believe little propositions so that when they drop the big ones on you, you're more suited for it. You have this background worldview already in your mind with just pure imagination. Notice that they have to construct it verbally for you or show you pictures, not actual photographs or evidence. They just show you these pictures and say, now you've got that image in your mind and now you can start explaining it. So if you ask, well, then wait a minute, how does the sun and the moon work? They then explain, they give a theory for it, even though there's no evidence that supports that. So then they start to select data that fits that false conclusion, and they ignore all of the counter evidence. This is a common way of trying to convince somebody of a conspiracy theory. They pick out certain anomalies or certain phenomenon and say, look at this thing right here, like that picture of the Earth with the supposed letters of sex on it. Right? I don't think that that's a very good argument, but this is how they start to select data and they fit that into the worldview by using it as a proof for their conspiracy theory. Here's a good example of that. So a lot of conspiracy theories think that the UN, the United Nations, has a picture of a flat Earth on it. And therefore, this diagram or this picture that the United Nations uses as their emblem is supposed to be proof of a flat Earth, like the United Nations is all in on this. Now that raises this question, right? Could that many governing body people be all in on the conspiracy theory and no one's revealing it? No one's coming out and saying, I'm fed up with this, right? I'm going to reveal it all. Nobody's doing that. the sheer size of a conspiracy that big would surely come to light with the number of people involved, the amount of secrets that they would have to keep. Why? Again, motivation. Why would they show the flat Earth picture if they're trying to hide the fact that the Earth is flat? It doesn't make any sense. But by showing you that picture, it gets people to start thinking about things in a new way. And they go, oh, well, that's the picture of the flat Earth you showed me just minutes ago. And now they've got you. They say, well, that is kind of weird. Suspicious, isn't it? And once they get you into that way of thinking, now we're starting to say, well, maybe the United Nations is in on this conspiracy theory, not just NASA and your government and the teachers and the scientists and the professors at college, right? It just gets bigger and bigger. They'll also oftentimes take a picture of the Earth or the horizon of the Earth and try to point out that the pictures are always flat. And they usually do this with selective photography, right? So they'll look at a very segmented picture here. And when you're looking at the picture, you say, oh yeah, that does look like a straight line, although you don't exactly see the full curvature of the Earth. The Earth is freaking huge. So even if it's taken at 120,000 feet, is that enough to be able to see a curve in that limited amount of space? So you're probably only looking at maybe 10% of the 360-degree spectrum. Whereas if we were to see this picture in real life, we would have approximately 180 degrees of vision to be able to see. And so you can actually see whether or not there's more curvature based on that 180-degree visualization. But they don't trust people who've been into space because you have to be an astronaut, you have to be an expert, and most people are not able to do that. Or they'll appeal to the fact that it's a fisheye lens, and therefore the fisheye lens distorts the picture, ignoring the fact that some of these pictures that they're showing are fisheye lenses, just taken at the right moment when it's flat, and therefore their pictures aren't always accurate. So if photography doesn't work for the spheroid Earth, then it doesn't work as a flat Earth theory either, because again, these pictures aren't really giving us the full set of data. So we're not getting the full picture there. Conspiracy theorists also spend more time casting doubt on the accepted theory than they do providing evidence for their own theory. And so I see this pattern a lot, that they oftentimes spend more time attacking the spheroid or the globe Earth model than they do actually presenting the flat Earth model. Why? Because the flat Earth model is absurd. If you know anything about science, or if you know anything about physics, or if you know anything about history. So we're going to talk about some of those examples in a minute. But if they can dismantle the globe Earth model, then they've got you in a position where now you're more susceptible to accepting these other propositions that they're entertaining them. And they will ask questions without answering them, as I indicated earlier. Here are some examples of flat Earth websites that'll say things like this. Why don't people fall off the southern hemisphere? I've seen that, where actually people trying to encourage someone, trying to get someone to believe in flat Earth, they'll actually ask that question, why don't people fall off the southern hemisphere? They might even have a globe in their hands and say, don't you think that people would fall off? And somebody who doesn't understand how gravity works might say, that is kind of weird. Like, wouldn't all the water just be draining off of the sides of the Earth and just falling? And they don't understand that gravity moves toward the center of mass. And this baffles people who don't understand physics. And a lot of the people who fall for this are usually people who are uneducated or don't have expertise in science or don't know a lot about how physics works, or just ignoring the evidence about how physics operates. So notice they just ask the question and leave it dangling. And if you don't know the answer, you have to fill it in with your own answer. And sometimes you might go, okay, I see where you're coming from. So they're saying that when you look at pictures of the Earth, right, they're saying that putting a person on the southern hemisphere is supposed to be normal, but the flat earthers is crazy. They think that this makes the globe head logic absurd. And so again, the visualization, I think, helps you to ask questions about this, because it does look weird to see somebody standing on the bottom of the Earth, because we tend to think of things as always moving downward. But that's not how gravity works. And therefore, flat earthers have to come up with a theory for what's causing everything to go downward if it's not the center of mass. So here's a picture that oftentimes toys with your mind, because when you see a ship upside down like that, your brain is trying to reverse it. Your brain is confused by this. And so they think that this is evidence somehow that the spheroid Earth does not work, is that a boat would surely fall upward, or would follow, further downward if it were on the southern hemisphere. They think that this is absurd. Here's another picture from a Flat Earth website that talks about Australia, and you see a helicopter in the air above Sydney. That just, again, plays tricks with your eyes. So notice there's something psychological happening to you at this moment. You're looking at these pictures, and your brain is trying to make sense of that and trying to flip the picture back around. And so you're saying, yeah, this doesn't make sense to me. How could Australia be on the bottom of the Earth if gravity pulls people downward? It doesn't make sense. Or they'll do even fancy tricks photography like this, because again, you say I'm crazy, but you think this is reality. Again, nobody's standing on the side of a mountain perpendicular to the Earth I guess that would be somewhere around the equator, right? This is something that's playing with your mind because they're trying to get you to question the adopted theory without ever acknowledging that gravity moves toward the center of mass, and therefore up and down are relative terms to the center of gravity. And if you don't understand how physics works, again, this is something that's going to play with your mind. So you have to have this working knowledge about what gravity is and how it operates in order to make sense of some of these models. They also ask things like, why don't planes fly into space when traveling in a straight line? So have you ever been on an airplane and you can kind of tell when the plane turns to one side or the other? Why doesn't the plane, if the Earth is curved, they even use this as an example. There's a lot of illustrations where they'll actually take a globe and they'll take a toy model airplane and be like, if it just goes in a straight line, wouldn't it eventually end up in space? Again, they don't understand how big the Earth is, and this picturization is not equivalent. Airplanes are extraordinarily tiny compared to the size of the planet, but with our lack of perspective, I don't think that most of us understand just how big the Earth really is. So it does raise a question in people's mind who don't understand this. And they say, that's true, right? Wouldn't we be constantly dipping down if we were going around a curved Earth? And the answer is we are doing that, but there's two things working against us. One of those is gravity, and the other one is that the plane is making incremental adjustments. They're just so minute that you never feel them. And so therefore, these things don't make sense. So the flat earthers will want to say things like this, that a gyroscope should be going straight up and down when you're on the top part of the Earth, but as soon as you start moving to one of the sides of the Earth, the gyroscope should be at a tilt. But it doesn't do that, and therefore they argue the Earth must be flat. Again, not understanding how gyroscopes work. Or if the Earth is a sphere, why are pilots not dipping their nose down and adjusting their altitudes as they're flying over the Earth? Again, people don't understand how planes operate. And again, planes are always making these adjustments, and they're always trying to defy gravity. So gravity is always working on them, pulling them down, but the plane itself, the engines and the lift under the wings are actually pushing the airplane up, and that's how planes maintain their altitude as they fly across the sky. Okay, so let's get into some other issues of flat earthers. They oftentimes talk about the distances between places and try to justify flat earth maps by saying that air travel between, say, South America and Africa makes more sense if you look at the travel from South Africa to South America. That a lot of the planes will go into the northern hemisphere and then back down to the hemisphere rather than just straight across. And so they say, those planes don't make a lot of sense. Those airline trips don't make a lot of sense. Why would you have to travel to the northern hemisphere just to go back to the southern hemisphere when you could just go in a straight line? And they think that the flat earth explains that by saying, see, if you draw this on our map, it makes a whole lot more sense. Going from South Africa in a flat earth model to, say, Australia would be more of a straight line in these cases. So they're saying that it would actually take a lot more time to go from Sydney, Australia to Santiago, Chile, because you'd have to be going through the northern hemisphere and you'd be wasting a lot of fuel and stuff like that. Well, there are a couple problems here. Number one, most people are not going from Sydney to Santiago. Most people are actually going to the United States, and therefore it's much easier for planes to book trips from Sydney to Chicago or Sydney to LA or from Chicago to Santiago rather than having to go straight from there. There's not enough passengers to justify flights. But those flights do exist, and I've actually proven that by looking at some of these websites I'm going to show you. So they're saying that on a flat earth model, if you look at those same flights from Sydney to Santiago, then it would be a straight line in those cases. And that makes a whole lot more sense when you're looking at a flat Earth model. And a lot of flights from North America to Europe or North America to China oftentimes go over the North Pole to get there. I actually did that when I was going to France, and the answer is that that's actually the shortest distance on a spheroid object. You can do that test yourself. Take a string and tie it between Chicago and Paris and see how the string moves across the northern parts going over Greenland as opposed to going, say, straight across the latitudes where you might see a longer string is required. It's a longer distance because the shortest distance between 2 points on a sphere actually goes above the latitudes that you would be flying on a flat Earth. But we see things on a flat map, and that's usually what confuses us about that. Here is actually some information about a flight that's going from Sydney to Los Angeles that I found on the website. I did some research, and it takes about 14 hours and 55 minutes. All three of those flights from Delta, Virgin Airlines, and other multiple airlines time it at 14 hours and 55 minutes. So that's from Sydney to Los Angeles. Got it? Okay, so let's also look at Los Angeles to Santiago and see how long the flights are there. All of the websites that I saw put it around 10 hours and 35 minutes from going from Los Angeles to Santiago. And here's the evidence that I have. Just taking a picture, you can see that that's the distance between Los Angeles to Santiago. One plane, because not a lot of planes go to Santiago, not a lot of people travel that distance, so it's not a very frequent flight. Now, if you're on a flat Earth, then you should simply add those two spectrums together and get you a Sydney to Santiago in what should be, 24 to 25 hours, maybe 25 and a half hours from Sydney to Santiago if you were traveling all the way across. But that's not the distance of the flights that I found. The flights from Sydney to Santiago are only 13 hours. How does a flat earther explain that? And here's the picture. So you have two flights there, one from LATAM, I guess is how you pronounce it, and the other's from Qantas, going from Australia to South America, and it only takes 13 hours and 0 minutes. How do you explain that? A nonstop flight should take twice as long as the flights to Los Angeles, but it doesn't. And so you have to explain this phenomenon. Are the airports lying? Is nobody getting on board those planes? That's what they claim. They say those flights are just on the web and no one's ever taking them. But there are people who get on those flights. People who do that. In fact, I'm hoping one day to be able to make that journey myself, just to prove people wrong. I'll videotape it if I can. I have to get a bunch of footage to pull that off. Even then, they'd probably say I doctored the footage, or I wasn't really in Santiago. I don't know what they're going to say, but we'll have to see there. So the distances don't make sense. And I think that also helps us to prove another case. This is a mathematical equation that I actually put together to try to show why the flat Earth model doesn't work either. So if you take a line from the North Pole to the South Pole in the globe Earth model, you can see that the distance around the edge of the Earth, right, because that line from the North Pole to the South Pole actually extends outward toward the equator and then back down, is about 12,500 miles from North Pole to South Pole. So if you keep that number the same and put that on the flat Earth, that means from the North Pole to some point in Antarctica, there should be 12,500 miles distance from that point to the other. Here's the problem. The land mass would not be the same, that is the square footage of the surface of the Earth would not be the same in these two models. In a spheroid Earth, the surface area of the planet, given that arc of a North Pole to South Pole, would be about 196 million square miles on a spheroid Earth. Area equals 4 pi times r squared. In the surface area of a flat disk, with the radius being the same distance, the surface area of that disk would be 485 million square miles. That's a huge difference between the two. That's a difference of 288 million square miles. So where's all of that extra surface? Where are the other 1.4 Earths that are supposed to be accounted for on the flat Earth? That's making the Earth a lot bigger in its surface area than it actually is. And again, you should be able to do tests there to see, well, okay, how far is it from Australia to South America? How far is it from the southern point of South America to the southern part of Africa? Measure those distances, and then maybe do the Magellan thing, right? Go all the way around Africa and back to Australia or something, and see how far it takes to get there. that there would have to be a lot more surface of the Earth under that model. Or if you kept the areas the same, right, just do this in reverse. Keep the area, the surface area of the planet the same so that the measurements that you take on Earth would be the same. Then notice that the distance between the North and the South Pole does not equal 12,500 miles. Therefore, it would have to shorten the distance between the North Pole and Antarctica, and you can't have that. In other words, you're going to mess up the distances one way or the other. You're either going to have to shrink the distance between the North Pole and the South Pole, or you're going to have to spread out the distances in the Southern Hemisphere, and you just can't do both. That is contrary to empirical data. Now, another tactic that they use is to beg the question. Flat earthers like to modify the evidence to fit their conclusion, rather than modifying their conclusion to follow from the evidence. Anyone who knows anything about logic knows that you first look at the evidence and you try to draw your conclusion from that evidence. Scientists do that. They look at data and they try to draw their conclusions from the data. They then check the data over and over again. That's where controlled experiments comes in, induction, blind controls, double-blind controls, so that you can actually see if that data continues to present the same conclusion over again. But that's not how conspiracy theorists work. They argue that their conclusion is true no matter what, and they keep modifying the evidence to fit it. So JFK's assassination is a good example of this, where people will say there had to have been a second shooter. That's their conclusion. What's their evidence? They say, oh, there was a man with an umbrella sitting there. And so that seems kind of fishy. Why would somebody be holding an umbrella on a bright sunny day in Dallas, Texas? That seems fishy to people. They assume there must be a gun inside the umbrella. Well, it turns out that that person was actually protesting JFK's rally, and so therefore one of the ways that people used to protest political figures was to carry these umbrellas. It was very popular in the early 1900s, and therefore this is just a way for people to try to silently, politely protest against the president. And therefore, the guy admitted, hey, this is me, here's the umbrella, and all of that came to nothing. So then people start saying, oh, well, maybe it was somebody on the bridge, and therefore they shot from the bridge. Or there's even a theory that says that somebody popped up from a manhole, shot JFK, and then popped back down before anyone could see him. Right? Notice, they just keep trying to come up with different theories. Someone was on the grassy knoll firing that no one else could see. Each one of those is trying to modify the evidence to try to make the conclusion to be true. And that's not how logic works. That's not how science works. Therefore, you shouldn't do it. But that's how flat earthers do it as well. So they construct a worldview that fits this example. They say, look, have you ever been to Antarctica? You don't know what Antarctica looks like, so therefore, maybe Antarctica is huge. And they even say things like, oh, there's a giant ice wall there where the ocean is being contained. And they even claim that there's like military along the ice wall because of some treaty that occurred back when World War I, World War II are going on, and we had stations in Antarctica. There was a treaty that says you're not allowed to have any kind of military presence on Antarctica. So therefore, they were thinking that it must be guarded by some kind of like collective shadow government that keeps people from going to Antarctica. Well, that's not true because ordinary civilians have been to Antarctica. There are people who live in Antarctica. They do experiments. Scientists have been there. And so you'd have to say that all of these people are in on this conspiracy theory, and you just start to lose the amount of credibility here, right? Because if even this guy who I know who's been to Antarctica is in on it, then that means that everybody is in on the conspiracy theory except you. And I don't see that as working, right? Can that be possible that 7.8 billion people are in on this conspiracy theory except for you, and you're the lone wolf who's figured it all out? That's impossible if all these people are lying. There's just too much counter data there. Now, it also begs the question because of the spotlight model. As I said, flat earthers often say that the sun and the moon move around the earth in sort of a clockwise fashion to create light on one side of the earth. But of course, that doesn't quite match the evidence that we see. So they adjust their evidence to fit their conclusion to say, this is how the sun and the moon operate, not this half of the sphere is in darkness because it's in the shadow of the sun's light. They want to say that it's a spotlight model. And their explanations lack any verifications because to say that there's a spotlight, well, how do you know it's a spotlight? Has anyone been up past the sun's, orbit to be able to see it from the other side? Can you explain how it moves in that circular fashion? Is there a track up there? And what's holding the track up? What's stopping the sun from falling to the earth? Or, why, how does the sun and the moon not collide with one another when there's an eclipse, or when there's, a lunar eclipse or a solar eclipse? None of these things can actually work. And so, there is empirical evidence that shows there actually is a shadow of the Earth at sunset. I've actually been on airplanes before. When you look out the window, you can actually see the shadow of the Earth as the nighttime comes on. The sun is setting on the horizon, you're up in the airplane, and you start to see a shadow forming on one side of the Earth. Why is that? Can a flat earther explain where this shadow is coming from? They also can't explain how lunar eclipses occur when the Earth actually creates a shadow on the moon. What explains that? Well, in a spheroid model, you can see that, right? That the sun is actually casting light on the Earth is casting a shadow onto the moon, and therefore you can actually see, as the Earth is passing in between the sun and the moon, you can actually see the curvature of that shadow. And that should be proof enough that the Earth is in fact round, at least, although a disk is round, it may not work for them. But how do you explain the fact that exactly half of the Earth is lit up at any given day, at any day of the year? How does the sunlight go from one point in the center of the flat Earth model to these extreme points without, let's say, going over to where the North Pole is, for example? On the equinox, it only covers these points of area on the Earth. So how do you explain why light travels further on the southern portions, but only shorter in the northern parts of the Earth? That doesn't make sense. And so you have to say that this is refraction? I don't get that. So Robbie Davison on Forbes magazine says this about this. He says, "We don't believe anything can fall off the edge because a big portion of the flat Earth community believes that we are actually in a dome, like a snow globe. So the sun, the moon, the stars are all inside," although that's not a common belief among flat earthers. He says it's very high, but all is contained inside, so there's no way to actually fall off the Earth. He's trying to argue the fact that you can't just fall off the ice shelf, that we're all contained within this snow globe. And again, if you picture a snow globe, you can be like, okay, right now I've got this image in my head. Maybe that explains the track that the sun and the moon are rotating on or something like that, but it doesn't explain how light works. So some people have then flipped that and said, okay, maybe the sun and the moon are outside of the snow globe, and that this refraction of going through a curved glass entity, of which they have no proof or evidence of, causes the light to be refracted in a way. But do that, right? Take a snow globe and shine a flashlight on it in a way that causes half of the snow globe to be lit up in that straight line that we showed on the flat disk of the base. How do you do that? Find a way in which refraction does this, and you just can't do it. So in order to fix the problems of sunsets, star fields, and planetary motions, lunar eclipses, atmospheric pressure, they appeal to this dome that goes over the Earth to try to fit that in. They're inserting new entities, if you will, to try to explain how other things that we already know how they work in a global Earth, they're trying to explain all of those phenomenon using their dome. So they're adjusting their theory in order to maintain their conclusion. And that's what shows some of the problems with conspiracy theories. Always adjusting the theory to try to make the conclusion be true. And sometimes that adjustment leads to contradictions. So the seasons, how do you explain then that the northern hemisphere has summer when the southern hemisphere has winter? And they say, well, then the sun has to move inward on its track to get closer to the Earth in the northern hemisphere, and then outward on its track in the winter so that the southern hemisphere can have its summer. And that would require the sun to actually move at different rates in those two different circles. The inner circle, the Tropic of Cancer, would actually allow for summer, but then the sun would have to move a lot slower to make it a 24-hour circle around that part of the Earth. But once it reaches our winter in the southern hemisphere's summer, once it's around the Tropic of Capricorn, then the sun would have to move a lot faster to make that complete circle within 24 hours. And yet the sun doesn't change speeds. So again, it's contradiction of our evidence. And when you look at the spotlight model, you only get a portion of the Earth being lit up by the spotlight. You don't really get that in the equinox, for example. The equinox, half the Earth would have to be exactly lit up and the other half would be in darkness. Or in December, most of the southern hemisphere, the sun never sets in Alaska when it's summer in the northern hemisphere, but when it's summer in the southern hemisphere, you'd have to see sunlight all year round in Antarctica. And so you can see the problems here. How do you get light to reflect in such a way that it's actually hitting the parts of Antarctica all day long, but yet there's these huge shadows in the middle? None of this makes sense in a flat Earth model. So what's the evidence? So there's no evidence that the Earth does look like a pizza. Right? There's no flat disk picture that we have. So we have no evidence of that. We have no evidence of a militarized ice wall. People need to just go to Antarctica and see it for themselves. There's no evidence that the sun is a spotlight. There's also no evidence of a dome covering the Earth. So you see the absence of evidence in all of these cases shows that this flat Earth conspiracy theory is not built on anything other than your imagination or pictures that they're drawing. Other people appeal to personal experience to say things like this: I don't feel like I'm spinning, and therefore my personal experience dictates that we must not be moving. Right? So they don't understand that, yes, we are moving 1,000 miles per hour, at the equator at least, and therefore it doesn't feel like we're spinning, so my personal experience is we're not moving, we're stationary. But they don't understand that the difference between the forces that are spinning around the Earth is actually outweighed by the force of gravity. And so you look at the centrifugal force that's moving around at the equator would be about 0.0312 meters per second squared. That's the force that's going around as we rotate around the Earth. Gravity is actually pulling us down with a force of 9.8 meters per second squared. So you can see that the force of gravity far outweighs any force of movement that's going to the side. And that's why when you're walking on a bus or on an airplane or on a train, you don't always feel the movements there. You can walk normally, both forward or backward, as long as there's no acceleration of the train or the airplane, or as long as they're not tipping one side or another. You get the point here, is that the force of gravity is oftentimes a lot stronger than these other things when you're moving in a car or in a plane. And that's why you don't feel yourself always hitting the back of the seat when you're sitting in a car. When it's accelerating, you do, because there's an increased force toward your back. But once you're at a steady 65 miles per hour, then you're just basically feeling the weight on your bottom. And the backrest is just holding you up because of gravity. So they ask the question, right, how do you explain the motion of the sun and the moon, or how do you explain things like the Coriolis effect? There's a good question. And they actually came up with an explanation for that, trying to appeal to electromagnetic waves or something like this. So they adjust their evidence to fit their conclusion. They say that what's actually causing the Coriolis effect is that as the sun and the moon go around with this magnetic waves that are pushing them apparently, it's actually creating these eddies that move to the right and to the left of the sun. And therefore, as the sun passes by, let's say, South America, it's actually creating these eddies that might cause your toilet bowls or water to spin in different directions in the north side of the planet versus the south side of the planet. And that's what's causing the Coriolis effect. So notice that hurricanes always go clockwise in the northern hemisphere, but counterclockwise in the southern hemisphere, or when you flush your toilet, or, all of these examples of tornadoes or weather phenomenon, you can see the Coriolis effect taking place in many different ways. Why does that happen? They're saying it's because the sun and the moon are causing these electromagnetic waves. But here's the problem with that. The Coriolis effect actually divides at the equator. But yet the sun and the moon, to make the seasons, has to move above the equator at certain points of the year and below the equator at other points of the year, which would actually supposedly cause the Coriolis effect to take place, at other sides of the equator, depending on which season it was. But it doesn't do that. Again, evidence doesn't fit the theory. So even though they're adjusting their evidence to fit their conclusion, their adjustments are creating contradictions with real life data that you can see by simple observation. Right? Look at the way the Coriolis effect affects things between the equator and the Tropic of Cancer and the equator and the Tropic of Capricorn, and you'll notice that it's always going to be the same, no matter where the sun is in its seasons. There's another test you can do. If you simply take a bunch of wooden sticks, the same height, and you place them onto a board, make sure they're exactly perpendicular, and if you can set these along one of the longitudes at various places, various latitudes of the Earth, you can measure the shadow of the sun. Now, if we're on a flat plane, those shadows that are created by these sticks should be completely linear in their distances. That as the sun gets further away, the distance of the shadow should grow the same amount for each increment of distance that you go away from the sun. But that's not what we see. The further you go to the north or the further you go to the south, you'll start to see that the distance move up exponentially, that the shadows become exponentially large when you get closer and closer to the North and the South Pole. And so again, you can do this experiment, and we have done experiments like that where you can actually measure the shadows in various places of the Earth to see what the curvature of the Earth is, and actually determine what the circumference of the Earth is. For example, you could actually do your own experiment without ever having gone to space. So this should be evidence enough that the Earth is spheroid. If the Earth was flat, it would have to look like this, but none of your experiments are going to look like that. So you can actually see that on a flat plane, right? Each one of those distances would increase by the same amount with all of these charts. This is just basic mathematics. So again, I told you that math is sort of like pure reason, but it has real world implications. When you do geometry in this way, you can see that on a flat plane, that these angles would have to be increasing longer and longer in the same distances as you angle outward. On a curved surface, it would be much different. In fact, one of the Greek philosophers named Eratosthenes actually proved this around 300 BCE. He was actually trying to argue that the shadows in Alexandria, Egypt, would have to be different than the shadows that were taking place in Cyrene. And so he actually did this experiment. There's a famous well back then that at a certain day of the year, the sunlight at a certain time of the day, that the sunlight would actually pour directly into that well with no shadows. And that was sort of an indication that at that point you know that the sunlight, the sunbeams, are going straight into the well. There's no shadows. So that is exactly right, up and down. So he figured out that if you can identify what that time is every year when that happens, you could actually measure another phenomenon, let's say a tower in this case, and see what the shadow is of that tower to determine whether or not the Earth was flat or round. It would also give you a measurement to see how big the Earth was, and he could kind of determine what the circumference of the Earth was based on how far that shadow was moved. And he did this test, and he was within 6 degrees of being correct, or 6% of being correct, excuse me. So he was off by a little bit, but he didn't have exact measurements with the shadow to be able to pull this off. But he was pretty close, and it did in fact show us, even 2,500 to 2,200 years ago, that the Earth was spheroid. So let's look at the magnitude of this conspiracy theory. If this were a giant conspiracy that, everyone's trying to pull over our eyes and make us sheep, right, that we're all supposed to wake up to, here are the number of people who would be involved in the cover-up. All of the airline industries would have to be in on this because they'd have to adjust their instruments to be able to account for flight patterns. They have to move. The flights themselves that travel different distances would have to be eliminated. No one would be allowed on those flights. The pilots would have to be in on it. All of the airport flight control personnel would have to be in on it. All international ship captains and their crews would have to be on it because a lot of ships can tell how far it is by sea, by ocean, when you're going from Africa to Australia or South America to Australia. All of NASA would be in on it, which of course is what the flat earth conspiracy theorists are claiming. The studio workers who filmed the moon landing would have to be in on this because this would have to mean that we didn't actually land on the moon, which is also another conspiracy theory that we can address, and that you can see that just adds to the problems of flat earthers. And all of the people who live in Antarctica, those people would have to be in on it because there are people who live and work there, and those people would have to be part of that conspiracy theory as well. All of the tourists who have ever visited Antarctica would have to be in on it because, again, there are people I know who've been there, and many people have testified they've been there. Those people would have to be lying if this was a big conspiracy as well. All of the airborne military powers that exist today would have to be in on it because there's obviously somebody stationed on Antarctica to enforce this ice wall that's being protected. All of the companies who run the GPS and satellite technologies would have to be in on it because those GPS and technologies have to be adjusted based on the curvature of the Earth. And so they would have to be in on this as well. All astronauts, all of the scientists who work with satellites and rockets, all of the governments who hold a stake in Antarctica would have to be in on it. And we can't even get our governments to agree, let alone, have some kind of conspiracy for people. I don't know how this would even work. All of the scientists who teach Earth science would have to be in on it, because they'd have to have arguments to prove to us that it's a globe Earth. All the philosophy professors who give lectures denouncing flat Earth conspiracy theories would have to be in on it as well. All astrophysicists, all geographers, all meteorologists who monitor weather patterns, they would have to be in on it, because they know a lot about how the Earth works and how it works given its spheroid shape. So why does all of this matter? We need to debunk the flat Earth conspiracy theory because conspiracy theorists have an agenda to erode trust in expertise. And that's leading to a lot of problems. If we lose trust in expertise, we lose scientific knowledge. We lose academic expertise, where people who are trained scholars and know a lot about certain phenomena are no longer trustworthy anymore, which means that our education is going to plummet in this country, which will make us lagging far behind all of the other countries who are excelling at science, who are excelling at mathematics, who are excelling at logic and reason. And we will start to plummet as a society if we do that. It also erodes trust in just common sense, right? We no longer can trust what people claim to know, widespread common knowledge, the popular explanations that we talked about at the beginning of this lecture. It also can erode trust in the government, because then you're saying, now I don't trust any form of government, no matter how good they may be, because they must be in on this as well. And that's just unnecessary. I mean, it's okay to have certain levels of distrust of the government, and we should hold the government accountable for their actions, otherwise they can become corrupt. But to not have any trust in them as some kind of Illuminati or aliens or conspirators plotting our demise with all of this stuff just destroys the fabric of our nation, and therefore we lose all form of law and order in our country. And all of those unifying worldviews that brings us together. One of the beauties of math and science is that it's sort of the universal language. Scientists around the world love to get together because they can talk to each other even though they speak different languages, even though they come from different nationalities or have different religious beliefs. They can come together because everyone can see the data themselves. They can replicate those experiments and test them and retest them. So I think it's clear that conspiracy theorists aren't just trying to convince us of a different worldview, they're trying to erode our trust in expertise. They even admit this, right? Here's a screenshot from one of the conspiracy theorists that actually just admit it. It's not about the shape of the Earth. It's about the deception. And that's meant to obviously get their readers fired up, right? Supposed to get angry at it. They're deceiving me. But it's actually the conspiracy theorists who are deceiving you. They're the ones you should be mad at. I don't encourage you to get angry at them, because they may be sincere about this and they're not going to respond to anger any more than they're going to respond to logic and counter evidence. So what we have to realize is how this affects us personally. And I think that's the most important part here. All of these lectures I give on conspiracy theories are meant to train people how to think about conspiracy theories so that you can start to figure it out for yourself. And that way we can actually see when there's a real conspiracy going on. But we have to have the right tools in place. And what usually happens is that when people first learn about something, they're filled with confidence in what's called the Dunning-Kruger effect. And the Dunning-Kruger effect basically says this: when somebody learns a little bit of information about something, they go from a point of ignorance, and therefore a lack of confidence, to suddenly being really confident about something because they learned something new and they're like, Eureka, I figured it out. Now, the more you learn, you start to question things. You're like, well, wait a minute, maybe I didn't know what I was talking about. I didn't learn enough about this science or this philosophy or this worldview to understand it properly. And so their confidence starts to go down eventually as they become more and more educated. And people do fall into a state of despair where they're like, you know what, maybe we don't know anything, because you start to see the limits of our human knowledge for the first time. And everybody goes through that effect. But the more you continue to learn, as expertise grows, you start to become more and more confident. Never to 100%, because even scientists will say we don't know anything 100%, except for maybe math and certain rules of logic. We can know those with certainty, but most of the things that we know about the world are based on probabilities and degrees of justification. And once you start to understand that, you realize how important expertise plays a role in all of this. That those people who study physics, who study chemistry, who study biology, who study geology, those people know what they're talking about, and you don't. And that's the thing we have to recognize. Most conspiracy theorists don't have expertise in their respective fields that they're applying to. They don't understand physics. They might learn something that they saw from a snippet on a YouTube video, or maybe they read a portion of a physics books and they become super confident, like they know everything that there is to know. But if they just learn a little bit further, they'd realize that there are mistakes that they're making. And that is why science needs to be self-confirming. There needs to be this checks and balances where other people can replicate your experiments and you can test these theories out. So why do people then engage in conspiracy theories? Because they're afraid of being duped. That's it. They don't want to be the person who falls for a conspiracy, because there are real conspiracy theories that have existed in the past and we don't want to fall prey to that. And they're also afraid of being wrong, right? We don't want to be incorrect. And so a lot of times this strong degree of confidence comes about because people are like, look, I'm so convinced in this worldview that if you prove me wrong, I look bad. It's embarrassing. And so there are psychological reasons why people hold on to conspiracy theories, because it makes them feel good. And also we just want to be contrary, don't we? I mean, I have a rebellious part of me that's just like, I want to defy the authorities, whatever they may be. I feel that sometimes, and sometimes that's good because it helps to keep the authorities in check. But taken to the extreme, it erodes our trust in those authorities. And if they're not really corrupt, then we're going to be doing some serious damage to our society. And we also tend to favor the underdog, right? Have you ever listened to music and you're the only person or one of the few people who likes this band? Eventually, when more people like that band, those few people start to not like them as much. Why? Because they're now seen as like the big and popular, right? So this happened with Nine Inch Nails or with Tori Amos or Tool. I'm just naming bands that when they became famous, people were like, no, you're mainstream now. We don't like you because you're too big. And then they start to cast suspicion on those people and say, okay, look, right, Jay-Z and Rihanna or all of these big names, U2, they're all part of the Illuminati. And that suddenly they become a conspiracy theory only because they're this big entity. It happens with everybody. So anyone who has power over you, you tend to become suspicious of, partly because you're afraid of the power that they have over you. And we also want to preserve our own uniqueness. If we have to conform to what the science says, or we have to conform to what the government says, or we have to conform to what religion says, right, it feels like we're losing some of our personal identity. And we want to be unique. And so people find this common ideology by joining conspiracy theories, and they can say, I fit into a group now, whereas I didn't fit into that other group, because it was so big, I was just another statistic. And so this helps people to kind of satisfy that psychological need to belong to something, to feel wanted, and to feel like you're in a group with a very tight-knit identity. And that's also how cults operate, isn't it? Because when cults form that sort of personal identity, they make you feel like you're loved, like you're important. And that's why people join them. And then also because conspiracy theories are exciting. I mean, let's face it, right? Whenever you're surfing around on the web or, watching YouTube or doom scrolling, you just keep reading more and more stuff and you're like, oh my gosh. And you suddenly become so convinced because you've seen it repeatedly enough on the internet that it makes you start to believe it. Just because it's repeated doesn't make it any more true. But people hear things over and over again and they start to believe these things. And therefore, it's just repetition. They're just hearing it over and over, embedding those ideas into their framework, their background knowledge, and now it becomes easier for them to accept those things. So here are some lessons that we can learn from all of this. Number one, we should be very slow to assent to any proposition when it's offered to us. Don't just buy whatever you hear. Question it. Ask yourself some questions and say, is this plausible? Does this match, other things that I know to be true? And do I know those things to be true? Always be questioning your own beliefs. Ask the person questions and say, how do you know this? Find out where they got that information. Was it a reliable source? Is there actually proof behind it? And then verify all the claims that lead to a conspiracy theory and say, okay, does this make sense? Does this part make sense? Can you check it? Is there evidence supporting it? That can require some personal observation, but it should require more of an inductive reason, right? If you're going to take that to the extremes, then you should be doing experiments on this and do those experiments repeatedly. Also, ask what the motivation is behind a conspiracy theorist. What would they be getting out of this? What's their agenda? Is it a political motivation? Are they trying to discredit science? Is it for religious purposes? Are they doing it because they're trying to dismember the people who are in power at this time, or whatever it is, to overthrow the government or to overthrow a particular person that they'd happen to disagree with? Also look for suppressed evidence. That's oftentimes the failure here, is that you look at the specific data, you look at these anomalies, you don't look at the counter evidence, and therefore you miss the boat. Check other sources. See if there's other information out there that will help you to see the bigger picture, and then maybe you can weigh the evidence for both theories against one another and see which one comes out with more weight to it. Also, look at the conspiracy theory in detail and demand precision. Don't rely on vague pictures. Don't rely on loose ideas, and say, well, what does the Earth really look like? What is the distance between the North and the South Pole? How far is it from Sydney to Santiago? How far is it from this city to this city? Do the measurements, take them in detail, and demand that precision. Conspiracy theories like to throw these ideas at you using vague terminology, and they don't oftentimes give you the precision that you need to know if it's true or not. Demand precision. So look at the details, pick things apart, and try to see if they're true. That's what science is trying to do. And then also look at things broadly as well. You need to look at the big picture and ask, does this view cohere with itself? Because sometimes you get lost in the forest just looking at the trees, that you forget to look at the big picture. You don't see the whole forest. And that's where those contradictions start to emerge. Like I said, the Coriolis effect does not work when the seasons change, with the sun moving closer to the North Pole in our summer and closer to the South Pole in our winter. That doesn't work with the Coriolis effect. That contradiction should prove, without a doubt, that the flat Earth model is not true. And then compare the details with the broader picture to see if there's any of these irregularities. You can actually look at the details, compare it to the big picture, and see if they fit together. And usually you can spot a problem when that happens. So the globe Earth model actually explains a lot of information about the way the world actually works, including solar eclipses, lunar eclipses, atmospheric pressure, the Coriolis effect, weather predictions, photography and video footages, planetary motions, the star field motions, gravity, convection. I didn't even talk about some of these things, right? The star field motion, why is it that the planets move in different orbits around the Earth if all of the other stars are moving in a circle? Right? The planets move backwards and forwards in our night sky. How is that even possible in a flat Earth model? Explain that. Convection, we didn't even talk about that, underneath the Earth, that in order to create electromagnetism, you need this convection going on underneath the surface of the Earth. The seasonal changes, southern hemisphere constellations. So again, I've been to the southern hemisphere. I've seen the Southern Cross. I know, right, how does the stars spin when you have a time-lapse camera in the southern hemisphere. Satellite relays and the International Space Station orbit. Flat Earth explains why it looks flat, why it feels like we're not moving, and nothing else. That's it. Your personal observations. It explains why the Earth looks like it's flat, why it feels like we're not moving. It doesn't do a good job of explaining any of those other things. It can't explain gravity. It can't explain lunar eclipses. It can't explain the planetary motions in the stars, and it can't explain the Coriolis effect. It fails in all of those attempts. And like I said, there are these contradictions. Seasonal changes versus the Coriolis effect. The summertime, daytime, nighttime areas of the Earth don't match up according to the flat Earth model. The sun outside the dome versus the sun inside the dome, those two things don't line up because they use them in different ways to answer those questions. That should be conclusive proof that the flat Earth conspiracy theory is a false theory. Thank you for watching. If you're interested in watching more of these, click subscribe. And if you'd like to hear more about conspiracy theories in general, I have a lot of other videos that I'll post links to at the end of this video. Take care and good luck hunting those conspiracy theories.